In this problem, we're multiplying a series of matrices. The first thing we want to do is b times a. So b times a, the first thing we're going to look at here is we want to study the dimensions of this. B is a 2 by 2, and a is a 2 by 1. Okay, so we have a 2 by 2 by a 2 by 1, so I'm going to write this out now. So we have b, which is 3, 4, 5, 2, and we have a 2 by 1, which is 2, 1. Now we can do this because we notice the inner dimensions are the same, meaning that I have the same number of columns here as I do the number of rows here, which means this guy can plot right on top and match up with numbers. So what does that mean? So this thing collapses down on top of this, the 3 and the 2 meet, and so I get 3 times 2. The operation, remember this is a sum product, is plus 4 times 1. And so now the tower kind of collapsed down to the next row, and I get 5 times 2. Just to be consistent here, I'll do 5 times 2 plus 2 times 1. And that turns out to be 3 times 2 is 6 plus 4 is 10. 5 times 2 is 10 plus 2 is 12. And so I get a 2 by 1 matrix, which I should expect because as long as the inner dimensions are the same, the resulting matrix is going to be have the dimensions of the outside dimensions. Okay, well now I'm asking, can I do a times b? Well, a is a 2 by 1 and b is a 2 by 2. So there's a problem here because now if I have my 2 by 1 and here I have my 2 by 2, and I take one column at a time, like this column, and I try to collapse it this way, well, there are two numbers here, but there's only one number in every single row. So it's not possible. Since these aren't the same, this cannot take place. And that's just by definition. It's sort of like adding and subtracting matrices. If you have a dimension mismatch, then that can't be done. Alright, c times a, we want to take this guy and multiply it down this guy. Well, you're also going to notice here that c is a 3 by 2 and a is a 2 by 1. Excuse me, so we will be able to do this because our inner dimensions are the same, and so our resulting matrix should be a 3 by 1. Okay, well, what's going to happen? We're going to take the C matrix, which is 9, 1, 0, 1, 2, 10, and we're going to multiply it by A, which is a 2 by 1. So this can be performed because as I drop this sideways, the 2 is going to come down this column, the 1 is going to come down this column, and every single time we multiply and add, we're going to form a new row. So we'll have 9 times 2 plus 1 times 1. We'll have 0 times 2 plus 1 times 1. We'll have 2 times 2 plus 10 times 1. And what does that amount to? Well, we get 18 plus 1 is 19. 0 plus, what do we have? This is a 1. 0 plus 1 is 1. 4 plus, what do we have here? 10 is 14. And so there's our resulting 3 by 1 matrix that we expect. Next we want to do c times b. Well, c times b is going to work out because we have here a 3 by 2 and here we have a 2 by 2, and we're multiplying them in the reverse order. So I'm going to write these down on the next page. Actually, I'm just going to go ahead and come down here and add this table one more time so we can see it. And so we're going to do c times b, and c times b is 9, 1, 0, 1, 2, 10 times 3, 4, 5, 2. So here we're going to have to collapse this column all the way down the rows. So that's going to form a new column of 3 rows. Because keep in mind this is a 3 by 2, this is a 2 by 2. Inner dimensions match, so I should end up with a 3 by 2. So what we're going to do is we're going to take, to form our first column, we're going to take this guy, collapse it this way, and we'll have 9 times 3 plus 1 times 5. Collapsing down to the next row, we have 0 times 3 plus 1 times 5. Then we have 2 times 3 plus 10 times 5. Well, that column is already crushed all the way down to the very bottom. Now we've got to take this guy and multiply it down to create our next column in the resulting matrix. So we'll have 9 times 4 plus 1 times 2. 0 times 4 plus 1 times 2, and then we'll have 2 times 4 plus 10 times 2. And so you're noticing a pattern. You see the 3 and the 5, the 4 and the 2, and then the original column in the initial matrix, the initial 2 columns. And so now we just have to compute. Of course, this is easier with a calculator. We're just doing it by hand to demonstrate for this problem. This is going to be 32. Then we're going to have 5. 6 plus 50 is 56. 36 plus 2 is 38. 0 plus 2 is 2. 8 plus, it's going to be 20. It's going to be 28. And there's our resulting 3 by 2 matrix as we had expected. And finally, A times C. Okay, so A is a 2 by 1 and C is a 3 by 2. And so because these guys don't match, we can't do this.